Okay, this is going to be a little quick tutorial video on the new mortise and tenon features in JointCAM. So you fire up JointCAM and click on the mortise and tenon button, and that'll take you to the new screen. Now be aware that as of right now there's a tenon only in the current version of JointCAM. The mortise portion has not been implemented yet. So we're going to go over real quick just how to do tenons on here. With mortise and tenons, you're going to be working with two different stock sizes. So you're going to have a tenon stock, tenon parameters, and mortise parameters over here. Tenon parameters over here. We can ignore the mortise for now. So when you're doing a cut of tenons, you're going to have your width of stock, which if you look down at the bottom in your machining options, the width is going to be the dimension that's facing you as you put it into the machine, and the thickness would be the smaller, not necessarily smaller, but from the machine towards you. And we'll cover that a little bit more detail in a few minutes here. Your tenon length is the length that you want your tenons to end up being after you machine away the material around them. Corner radius is the radius on the corners of the tenons. And you can have, the tenons have to have a radius because the mortises are cut with a router bit, so they're going to have a radius in the mortise, so the tenons need to have a matching radius. The corner radius can be, it's going to have to be at least as big as your tool, but it can't be larger than the width of your, half the width of your tenon. So if you see our tool is 0.25, if we set it to 0.124 and calculate, you'll get an error that the radius must be greater than or equal to the tool radius. And there may or may not be an error message if you set it too large right now, so we're not going to try that. So we'll set it to 0.2 for right now. Clearance is, well, missed a few. Use tool radius. If you check use tool radius, the actual tool radius will be used for the corner radius rather than this value here. Loose tenons will actually cut a mortise into your board. This is not yet implemented, so as of right now it doesn't do anything. Clearance is the fit of your mortise in your tenons. Whatever the clearance is, it'll be the gap around the tenon, or the mortise will be that much larger, will be the clearance value larger than the tenon. Step over percentage is when you're machining that, what percentage of the tool width you want to remove at one time. And then the finish pass is basically when the tenons are machined, it basically does a roughing pass, removes all the excess material, and then does a final pass around each tenon. And that finish pass is what the final pass will end up being. Okay, let's see. And then there's our standard JointCAM tool parameters. You're going to be using a straight bit. An upcut spiral is what I would recommend. And then we'll get into the parameters here and actual tenons. I tried to make this as flexible as possible and give you a lot of options without being too complex. So basically you have two different choices when you're doing tenons. You can have a grid of 3x3 tenons, up to 3x3. You can have 1, 2, or 3, up from 1 to 9 tenons, or you can have an array. So first we'll start with the grid. Each one is going to have 3 rows. So if we start out with just one row, we'll uncheck 2 and 3, and then we'll have an offset and a width, and then a length offset and a width. And we'll set these to 0 to start out. We can just hit clear all and 0 them all out and say we'll go 0.5 and 1 and calculate. And we got an error message because the offset all got cleared off. 0.5, we'll go 0.5 and 1 here and calculate. Let's make this a different number so it's a little easier to see. Okay, so the first offset up here at the top, the tenon rows. Think of it as a spreadsheet. We have rows and columns, rows left to right, columns top to bottom. So the first row, we're going to make this width a little bit bigger just so it's easier to see. The width offset would be from the top of your part. I put a little note here about the origin on a left-hand joint. So the width is from the top, which is up against the fence, up against not the fence, but the fence would be on your left side, the vertical fence, but against your fixture would be the top edge. So your offset is a 1/2 inch, 0.5, and the width of your tenon is 1 inch. So from here, top edge to bottom is 1 inch. And then the length offset is also 0.5, and the length of the tenon is 2. And you can change those to pretty much anything you want. If you change the corner radius to 0.5, as you have a 1 inch width, then you'll have basically rounded oval shaped tenons. So let's see. Okay, so if we want to change the, say, the width offset to a 1 inch, we'll see that it moves down to 1 inch, 1 and 1. And we'll go back there. We'll make the width a little smaller and the length smaller. And you can have up to 3 in the grid function. In the grid option, you can have 3 tenons per row. So say we go 0.5, 0.5, 0.5, 0.5, and we have 3 tenons now. And the offset can be 1, and they'll move over. You can change the sizes. And that's pretty much all there is to that. You can add another row, and the offset, when you add another row, the offset is going to be the distance between the 2 rows. So if I say 1 and a width of 0.75, and we'll have an offset there of 1 and a length of 1. Now the offset of 1 up here in the row 2 offset is the space between the tenons this way, top to bottom. I unchecked it, we'll check it back again. And then the length offset would be from the edge from your fence to your start of your tenon, which is 1 and 1. Length of 1, offset of 1. Now there's another option here called absolute offsets. Now rather than having the offset specify the space, it now specifies the actual position from the edge. So if I calculate this, they all get jumbled together because now the offsets are all absolute from the edges. So now if we have 1/2 and 1/2, so we're at a total of 1 inch from the edge, and this offset is 1, that means it's going to be touching. So we need to bump this one up. And then now this offset is a 1/2 an inch, and this one is 1 1/2, but it's absolute, so it goes from the edge. And then the same thing with these. These offsets would need to be larger because they're now absolute and not spaces in between. And then if you change them back, and then you're going to get drastically different results. So 2 different ways to lay them out, depending on how you want to do it, because absolute may be easier because you're not adding numbers together if you know exactly where you want them to go. Now the other option, now you can do, as I said, you have 3 per row, 3 tenons per row. You can't do the first and the third row. So you have to start out with row number 1. You can't turn off, you can never turn off row number 1. If you turn off row number 2, row 3 automatically turns off. So if you want one at the top, one at the bottom, it would be row 1 and row 2. You can't have row 1 and row 3. You can't have row 2 only or row 3 only. You always have row 1, and then you have to go incrementally. Now the array function, which I figured might be useful for somebody, say, building cabinet parts, and you want to put something like a group of mortises or tenons, sort of like dowels. The array lets you make as many as you want tenons. So instead of having each one offset, you have an original. You have the row offset is the same as the grid, but the length offsets are a little different. So you have your first length offset, which is a 1/2, which would be, it's not going to work because my values are 0. So we'll say we'll put 1 in here, and then the array offset doesn't really matter. So 0.5 in the length offset is what we have from the left to the start of the tenon. If we change it to 1, you can see that it shifts over a little bit. You can have as many as you want as long as your stock is big enough to handle them. And then the offset is the space between tenons. So say we put a 0.5, we now have 3. Say if our stock was 12 inches, then we could put, say, 7 of them. And you have 3 rows again, so you can do something similar to that. And we'll make the size a little different and the spacing a little different. And then you have another row. The way I envision this is that if you had a cabinet side, you would have a row for the top, a row for the bottom, and then maybe a row for a fixed shelf. And actually this is has more to do with the mortises than the tenons, because on something like that you're only going to have one row, and your part's probably going to be something much smaller than that. And you're going to have probably a part like that would be the side of your, say, a top or a bottom of your cabinet, and the side would have the all the holes in it for those tenons to fit into. You also have 2 preview options here, so we'll go back and look at the Mortise Preview real quick. Say in our example, say the width would be, say, 30 inches. And then you can start to see how you would do it on how a cabinet side would be laid out, but actually it's going to be a little bit different. I still have some things to iron out on when I get to this part, and I'm trying to make it as simple as possible, and once I got it figured out, it'll be a lot easier to cover. So basically that's all there is to it. There's not a whole lot. It's pretty simple. You enter your tenon sizes where you want them to be, and that's it. And then as I said, right now it's tenons only, so you can set it to mortise. You won't get any G-code. They'll rotate 90 degrees. I'll talk about that later. So as of right now, tenons only. You can cut lefts and rights. Lefts only, rights only. And unlike some of the other joints, so I think it's mostly half-plane dovetails that are opposite, but left joints are when you're facing your machine where you mount the parts. Left is left, right is right. The preview is the left. Let's go back to something more normal size, and we'll get rid of that, and we'll go back to what we had here. So the left hand joint is over here on the left. The origin will be up here, and then we'll go and I'll just kind of show you real quick how that works out. I got a little model here in Fusion 360. So here's my machine, and then here's my 2 pieces of stock that I'm going to cut tenons with. Now on my machine, this is the y-axis from left to right here in front of the machine. X starts over 0 over here and goes plus as it goes to the back. Some people have this as their X, so we'll start with the y-axis. If this is a y-axis, then your origin is going to be over here on this corner here. The back corner against the fence is your Y0. This is actually X0, Y0. Y0 and Y gets larger as it goes off to the left. X gets larger as it goes off to the right. And that's pretty much it. The Z0 is the top of your part, top of your stock. You set your Z0 there. Now if this is your X-axis, then your origin is going to be over here. X0, Y0, X plus moving off to the right, Y plus moving away from you, back to the back. So basically you're going to set your Z0 at the top, and then you're going to machine them, and you're going to end up with tenons, left hand, right hand, opposite. One will be opposite the other one. And same as with the other joints, your machine width is the distance between your 2 fences, which would be the outer edge to outer edge. And that's not much to it. That's what you're going to get. Put them on your machine and run them, and you're going to get tenons. And we'll go back to JointCAM real quick, and that's pretty much all there is to it. And you can load your project, save your project, write your G-code. Same as all the other joints. Hopefully it's pretty simple. This is not the best video, I understand that, but I wanted to get something out for people to do some testing. I know there's going to be some bugs in there, mostly to do with error messages that should be there and aren't there, or maybe cause some problems when they shouldn't. But for the most part, I think it works pretty good so far. I've only done one test, and then I did a lot of cleaning up after that, and I think I got most of the bugs worked out. So let me know what you think, and if you have any questions, feel free to always email me, support@gforcecnc.com. Thanks for watching, and I'm going to try to do the best I can to get this mortises out to you quick. Thanks, guys.